Hello, class 10 board exam appeared students. Hope you are enjoying the lecture of class 11 physics. This is the third lockdown special physics class, basics of physics. Today you will know about dimension, uses of dimension, homogeneity of dimension in an equation, conversion of units. So, if velocity, time, force were chosen as basic quantities, find dimensions of mass. Dimensionally, force is equal to mass into acceleration, which is equal to mass. Acceleration is velocity by time, v by t, or mass is equal to force into time by velocity, or mass is equal to F T V inverse. This is the dimensions of mass. Next, the distance covered by a particle in time t is given by x is equal to a plus bt plus ct square plus dtq. Find the dimensions of a, b, c, d. In this given equation, there are 5 terms. So, all of them should have same dimensions. Since x is equal to length L, remaining 4 quantities should have same dimensions of length. So now A is equal to, right hand side, A is equal to length is equal to L. BT is equal to L. This implies B is equal to L T inverse. CT square is equal to L. This implies C is equal to L T to the power minus 2. DTQ is equal to L. This implies D is equal to L T to the power minus 3. So next we will discuss about homogeneity of dimensions in an equation. It means the dimensions of all terms in an equation are same. So let us check this. Homogeneity of dimensions in an equation. So first we will see which equations you know. You know equations of motion. First 3 equations of motion. V is equal to u plus at, S is equal to ut plus half at square, v square minus u square is equal to 2as. So first we will see v is equal to u plus at. V is, here u is initial velocity, v is final velocity, both are velocities. So velocity is equal to length by time is equal to L T inverse. Here also another velocity. Velocity is equal to length by time is equal to L T inverse. Then AT, acceleration into time. Acceleration into time. Acceleration is velocity by time. Velocity is again length by time. So length by time by time into time is equal to length by time square into time is equal to L by T is equal to LT inverse. So in these three cases here LT inverse, LT inverse, LT inverse, so all are same here. So this equation is correct. S is equal to ut plus half 80 square. We will check this one. S is distance length, ut velocity time, ut is equal to velocity into time is equal to length by time into time is equal to L. Half 80 square. Half 80 square is equal to, take 80 square, acceleration time square. Acceleration is velocity by time, length by time by time. So length by time by time 8 t square here into t square. So is equal to length by time square or L by t square into t square. Again this is L. So see here for S LHS, here we got L, here also for UT L, for AT square L. So this equation is also correct. So the equation is correct as far as the dimensions are concerned. Then conversion of units. This is very interesting. Conversion of units. Conversion of units. In the system of units, magnitude of physical quantity remains same. Suppose U1, U1 and U2 are units of measurement of a physical quantity Q, and N1 and N2 are the corresponding numerical values. So we can write Q is equal to N1 U1 is equal to N2 U2. Let us consider M1, L1, T1 as the sizes of fundamental units of mass, length, time in one system. Likewise, M2, L2, T2 be the corresponding units in another system. If the dimensional formula of quantity Q is M to the power A, L to the power B, T to the power C, then U1 is equal to M1 whole to the power A, L1 whole to the power B, T1 whole to the power C, and U2 is equal to M2 to the power A, L2 to the power B, T2 to the power C. So N1 whole bracket M1 to the power A, L1 to the power B, T1 to the power C is equal to N2 whole bracket M2 whole to the power A, L2 to the power B, T2 to the power C, or N2 is equal to N1, here M1 to the power A, here M2 to the power A. So dividing this we get M1 by M2 whole to the power A, likewise L1 L2 L1 by L2 whole to the power B, T1 by T2 whole to the power C. So this is the equation. N2 is equal to N1, M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 whole to the power C, which is used to find numerical value in new system of units. So let us understand by one example. To convert 1 Newton to dyne. 1 Newton to dyne. 1 Newton is equal to how much dyne, and how to convert this. First of all, what is 1 Newton? Whose unit is Newton? SI unit of force is Newton is SI unit of force. SI unit of force. And dyne is CGS unit of force. CGS unit of force is dyne. So we'll use this formula. So for this, first let us write the dimensional formula of force. Let us write the dimensional formula of force. Dimensional formula of force is m to the power 1, L to the power 1, T to the power minus 2. So here A is equal to 1, A is equal to 1, B is equal to 1, C is equal to minus 2. Here A is equal to 1, B is equal to 1, C is equal to minus 2. Then one side write SI units, one side CGS. SI system and in CGS system. In SI system here, M1 is equal to 1000 kg. Corresponding to this, in CGS unit, M2 is equal to 1 gram. L1 is equal to 1 meter, which is equal to 100 centimeter. L2 is equal to, in CGS, 1 centimeter. T1 is equal to 1 second. Here also in CGS, T2 is equal to 1 second. And N1 is equal to 1 Newton. It is given in question. You have to find out N2 how much and in dyne. So for this, the formula N2 is equal to N1 whole to the power N1 bracket M1 by M2 whole to the power A, L1 by L2 whole to the power B, T1 by T2 whole to the power C. N1 is equal to 1, M1 is equal to 1000 by M2 is 1 whole to the power A is 1, L1 is 100, L2 is 1 whole to the power B is 1, T1 is 1, T2 is 1 whole to the power C is equal to minus 2. Simplifying this, 1 into 1000 into 100 to 1 is equal to 1, 2, 3, 4, 5 zeros is equal to 10 to the power 5. This implies 1 Newton is equal to 10 to the power 5 dyne. This is the answer. This is how to convert Newton to dyne. Likewise, you can also convert 1 joule into Arch. So 1 joule is equal to how much Arch? 10 to the power 7 Arch. Like this, find out with this formula. Then we will see another example from CGS system to SI unit. So question is like this: the value of a universal gravitational constant capital G in CGS system is 6.67 into 10 to the power minus 8 dyne centimeter square by gram square. Calculate the value in SI units. So for universal gravitational constant, we don't know the formula. F is equal to G m1 m2 by r square. F is equal to G m1 m2 by r square, or G is equal to F r square by m1 m2. Now this dimensional formula for this G is equal to F r square. F is force, m1 L1 t to the power minus 2, r square, r is here L square by m1 m2 m. So m to the power 1 L to the power 1 t to the power minus 2 by m and here L square. So it is equal to m to the power minus 1 L to the power 3 t to the power minus 2. So here A is equal to minus 1, B is equal to 3, C is equal to minus 2. And putting in the formula this, but this before this, what we will do here, CGS to SI unit. So this side first we will write CGS units and here SI units. In CGS here N1 is given 6.67 into 10 to the power minus 8. N2 is asked. M1 is equal to 1 gram. M2 is equal to 1 kg, which is equal to 1000 gram. L1 is equal to 1 centimeter. L2 is equal to 1 meter, which is equal to 100 centimeter. T1 is 1 second. T2 is 1 second. And formula is N2 is equal to N1 M1 by M2 whole to the power A, L1 by L2 whole to the power B, then T1 by T2 whole to the power C. Or N2 is equal to N1. N1 put the value 6.67 into 10 to the power minus 8. M1. M1 is 1. M2 is 1000. 1 by 1000 whole to the power A. A is minus 1. A is minus 1. Then L1 by L2. 1 by 100 whole to the power B. B is 3. Then T1 by T2 1 by 1 whole to the power C. C is minus 2. Simplifying 6.67 into 10 to the power minus 8. This is coming 10 to the power minus 3, which is equal to 6.67 into 10 to the power minus 11. This is N2. This means In SI units, G is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square, or this can be written as 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. This is the answer. So exactly like this, you practice more and enjoy the learning. Keep in touch. Thank you.